Hello everybody, today I can combine logarithms using log rules by applying power rule first and product and quotient rule last. So let's start by talking about our rules again, but this time I'm going to write them backwards because we're going to be going in the backwards order that we did in the previous lesson. If I see log A plus log B, if I'm adding logs, to make that into a single log, the addition becomes multiplication. If I see a minus between two logs, to make it into a single log, my subtraction becomes division. And if I see a number in front of the log, well, that came from the exponent, so I put that back in the exponent. Addition becomes multiplication, subtraction becomes division, and the number in front goes back to the exponent. The other key for this is, if I'm combining into a single log, make sure you write log once. The whole point is to write it as a single log, so write it once, and everything else kind of falls into place after that. Log base 830 minus log base 82. So if I'm looking to combine, I'm looking for addition or subtraction. I see subtraction, subtraction becomes division. So I'm going to write log base 8 once, because it's log base 8, that's why I write log base 8. The subtraction becomes division, and it's 30 over 2. 30 over 2 is 15. Now, if I can easily evaluate it, I will. This one I can't, so I'm going to leave it like that. I don't know why I skipped number 1, by the way. We'll go back to number 1. But if I see subtraction, it becomes division. I write the log once with whatever base is given. And then, again, because subtraction becomes division, I just divide the first number by the second number. And if they divide them. Again, I see division here. The log is base 3. Subtraction becomes division, so it becomes 54 over 2. 54 divided by 2 is 27. Now this one I would go further with because I know that 3 to the third power is 27. However, that is not the objective of this lesson. The objective of this lesson is to get to this point, so I'm fine with that. But if you understand the first lesson that we did in logs, hopefully you know when you see log base 3 of 27, it means the answer is 3, because 3 to the third power is 27. Now, if you see a number in front, like I said at the beginning, make sure you apply the power rule first. So, the number in front came from the exponent. We learned that in the last lesson, so put it back where it started from. So I'm going to start by writing log of x cubed plus log of y to the 5th. Now, I want to combine them. Addition becomes multiplication. I write log once. There is no base. Of course, it has the imaginary 10. And I multiply. So x cubed times y to the 5th is just x cubed y to the 5th, and you're done. So apply the power rule first. If you see a coefficient, bring it back into the exponent. And then you combine them, write log once, addition becomes multiplication. All right, no powers here. So I'm going to write it as a single log. So I write log base 5 once, 20. Subtraction becomes division. 4 goes on the bottom. Now here's where it's a little bit tricky. Plus log base 5y. So, does it go on the top or does it go on the bottom? Is it 4 times y or is it 20 times y? Well, since there's no parentheses around it, think of it this way. If it has a minus in front of it, it goes to the bottom. If it has a plus in front of it, it goes to the top. So that y will go to the top. If there were parentheses around it like this, if that were the case, then the y would go to the bottom. However, there's not, so it won't. From here, we simplify it if we can. 20y divided by 4 is 5y. I can't do anything more with that. That's my answer. Why don't you try number 7 and 8 on your own right now? So please pause, try 7 and 8 on your own, and then unpause. Okay, so first we apply our power rule. Since there's a number in front, we bring that back to the exponent. So that becomes log x squared minus log y cubed. Now I combine it into a single log. Subtraction becomes division, x squared over y to the third. Number 8 I asked you to do. I don't see any powers, so I just write log base 4. Subtraction becomes division, 60 divided by 4. Since it's plus log base 4 of x, that x goes on top. And if I can simplify it, I do. 60x divided by 4 is 15x. That's your answer. Let's take a look at these multiple choice ones now. You know what? Why don't you try number 9 on your own? So please pause it. Try number 9 on your own, and then we'll go over it. Okay, now that you tried number 9 on your own, I apply my power rule first. So that becomes log m to the 1/2 minus log n cubed. Subtraction becomes division. So it becomes m to the 1/2 divided by log n cubed. Now I see a fractional exponent. Radicals are fractional exponents. So the 1/2 power is the regular radical. Oh, I wrote log twice there. That's unfortunate. Let me just fix that quick. Again, I didn't follow my own rule. When you're combining into a single log, you're writing log once. And that's it. I look for that as my answer, and it is choice 4. Okay, I'm going to give you a little bit of a hint on number 10 to get started. Well, maybe we'll go through it. We'll see. It wants to know what x equals, and it's giving you log x. So the first thing you need to do is combine this into a single log. So apply your power rule first, then your product quotient rules. I'll give you about 20 seconds to do that on the right-hand side. Okay, power rule first. Log a squared plus log b. Now I combine into a single log. I write log once. Addition becomes multiplication, so I'm multiplying a squared and b. So I have log x equals log a squared b. So if I know what x equals, I just kind of drop the logs, and x equals a squared b. All right, I'm going to give you a little heads up. 11 is a very challenging question. 12 and 13, not so much. So here's what I want you to do. Oops, what just happened? All right, something crashed, but I'm good. So 11 is a very challenging question. I'm just going to put that out there. 12 and 13, not so much, even though it might look a little scary. Is this frozen now too? Maybe. Oh, there we go. So here's what I want you to do. I want you to try number... now this thing is really acting up. So I want you to try number 12 on your own right now. And then I'm just going to jump back to number 11 after that, which is, again, a little bit challenging. And then we'll go from there. So try 12 on your own. So pause, try 12 on your own. Then I'll go over it. And then I'll go over number 11 with you. All right. It's going to let me write on this thing. No. Okay. So I want to apply my power rules first. So I'm going to put all my coefficients back at the exponent. So I have log base bx equals log base b p cubed minus log base b t squared plus log base b r to the 1/2. Now I'm going to rewrite it as a single log. So I'm going to write log base b once. So I'm done writing log. Subtraction becomes division. So it's p cubed over. Now, since this is all in parentheses, this is all going to go in the bottom. So it's going to be the t squared on the bottom, and it's going to be the r to the 1/2 on the bottom. So log base bx equals log base b. The only thing I can do is that fractional exponent I can make into a radical. It's not that you have to, but if it's multiple choice, you're going to likely see it that way. It wants to know what x is, so I can kind of just drop the log base off. And x equals p cubed over t squared rad r. And that's your answer, choice 4. Now, as I promised, I'm going to go over number 11, which is tricky, but I will go over it with you if this thing unfreezes, because this thing is acting up a bit. Oh, here we go. All right, so again, this is a challenging question, but I'm going to go over it with you. And this thing really wants to freeze. All right, so it wants log x. So I need to get log x alone on one side. So I'm going to start by adding log of 2a to both sides. And I get log x squared equals log 3a plus log 2a. Now, I want to make this into a single log on the right-hand side. So a plus becomes multiplication. So it becomes log of 3a times 2a, which is log 6a squared. Now, I don't want log x squared, I want log x. So now I'm going to have to apply my rules again. On my left-hand side, all I can do is put the 2 in front. On the right-hand side, well, I ended up with multiplication again. So I need to break that into log 6 plus log a squared. Power rule again. 2 log x equals log 6 plus 2 log a. And now again, I don't want log x, 2 log x, I want log x, so I divide by 2. When I do that, I'm kind of out of space here, and this thing, oh, it's not really letting me do anything. So, log 6 over 2 becomes 1/2 log 6. 2 log a over 2, the 2's cancel, I end up with log a. That's my answer. So this was definitely a tricky question, and hopefully you're able to follow it, but like you might be saying, well, how am I going to come up with that on my own? I don't have a good answer for you. It's a challenging question, but that's how you do it. But the lesson itself shouldn't be that challenging. You're going to combine logs by using your log rules. Apply your power rule first, your product and quotient rule last. So again, if you see a coefficient, put that back in the exponent first. Once you do that, you're going to write the log once. Subtraction becomes division. Addition becomes multiplication. And then if you need to put it back into a radical because you see a fractional exponent, you do that. Your classwork/homework is to finish this. I hope everybody has a great day.